So this is section 12.3. It's trig functions of general angles. And we're going to break this into two major topics in this section. We'll do both of them today. Part 1 is finding the trig values of angles greater than 90 or less than 0 degrees. And part 2 is about reference angles. So we've found trig values of 30, 60, 45. You found trig values of angles that were always in an acute right triangle, like acute angles of a right triangle. Well, now we're going to find trig values. It's possible to find trig values of angles that are bigger than 90 and less than 0. So this question says, the point -3, 6 is a point on the terminal side of theta in standard position. Find the exact values of the 6 trig functions for theta. So we're going to start by drawing a picture. Okay, so we have a terminal side of theta. So our initial side is here. And then -3, 6 would be about here. That's the point -3, 6. I'm just going to label it with a P because that's our given point. And that's on the terminal side, right? So here's our terminal side of the angle. Theta would be this angle here, right? We don't know how many degrees theta is, but we know that that is theta. Find the exact values of the six trig functions for theta. So I want to find sine of theta, cosine theta, tangent theta. And I can do this without knowing the actual degrees of theta. Sine is opposite over hypotenuse from SOHCAHTOA. This is a little bit confusing part here. In order to find sine of theta, we're actually going to use a different angle. We're going to use the angle in this space right here. We call it theta prime, and that's the reference angle. Okay, we're going to spend more time on reference angles in the next part. But we're going to drop down from the P straight to the x-axis, and that's going to be our right angle. And so here we've created this right triangle. And we're going to find sine of this theta prime angle, and that will be the same sine of our theta. And it's a little confusing because you're just going to have to trust me on this one. There is a relationship between this. It shows up more in the graphing section, how this is all connected. But for now, you just kind of have to trust me that I'm right on this. So we know that this is -3, and we know that this is 6. Right? I'm getting that from this point. So -3 to the left and 6 up. Notice that I'm putting the negative sign on a side of a triangle. This is going to allow me to get the correct sign, it's not sine trig function, but correct plus or minus sign on my final answer. So now the next thing I would do is find the hypotenuse by doing a squared plus b squared equals c squared. So -3 squared. Right? So we've got, this is all going to become 45. So square root both sides, and then simplify. It says exact value, which means like we're not doing any decimals. So my hypotenuse is 3√5. Once you've drawn that triangle, you can now answer all of the questions about the 6 trig functions. Right? So just to recap, we drew the angle, right, in blue. We drew theta. From the point P, we dropped straight to the x-axis and created a right triangle there. This is called our theta prime. We labeled our sides, found the missing side, and now we're going to do SOHCAHTOA. What happens if P is in a different quadrant? If P is down here, if this is my P, then I would go straight up to the x-axis. So really when you draw your right triangle, We call this the bow tie. Your right triangle should either be this, right? This, this, or this. Kind of looks like a bow tie, right? So your right triangle should be one of those right triangles, and your theta prime would be inside each of those. And that's always what your triangle should look like as we proceed for the rest of the chapter, right? So think about the bow tie. Okay. So now, I'm just going to do SOHCAHTOA with this. So if you want to actually pause the video, you can go ahead and find all the 6 trig functions of that pink triangle. So here I'm going to simplify, and then I'm going to rationalize. So sine of theta is 2 root 5 over 5. Not a bad idea to immediately do cosecant of theta. When I do the reciprocal, I'm not going to flip the final answer. I'm actually going to go back to this step right here and flip that. And I'm picking that one because then I can tell I don't have to rationalize. Right? If you flip the final answer, then you'll have to rationalize the denominator. It's just a little bit more work. Cosine of theta would be negative 3 over 3 root 5, which becomes negative root 5 over 5 once you simplify and rationalize it. Secant of theta is negative root 5. Tangent of theta is 6 over negative 3, which becomes negative 2. And cotangent of theta is negative 1/2. Right? Now, you can draw this picture every time and do the problem this way. If you do a few examples, you will notice a little bit of a shortcut, right? Some of you like to memorize things. This would be something you could memorize. So every time you draw your triangle, no matter what quadrant you're in, this theta prime, right? Your sine of theta is opposite over hypotenuse. And what happens is your opposite side is always the y value, and your hypotenuse side is always this radius here, or like the hypotenuse, the c value, right? Cosine is always adjacent, which will always be the x value, over the hypotenuse, which is again, that r value, the radius. Now they're calling it a radius because we're going to talk about the fact that there's going to be a circle here. And so that's the radius of that circle. Again, we're kind of getting ahead of ourselves because that information comes in a different chapter, section. And then tangent is going to be your opposite over your adjacent, and they're saying x can't be 0 because of domain errors. So let me just draw another quadrant for you, so that you can see how this works. So if my triangle ended up being here, right, because this is where the terminal side was, right, here's my original angle. Say my original angle was here. This is the terminal side. That's my big theta, right? The pink is your triangle that you're using to do SOHCAHTOA with, right? Because we go straight from the point P and we go straight to the x-axis, right? And that's your right triangle. So if you look, for SOHCAHTOA, the opposite side is going to be that y value, right? And then the hypotenuse would be this r value here, right? So you can memorize these, right? And that will get you the answer a little bit faster. Or you could draw a picture and do SOHCAHTOA every time. So we're going to do another example, and I'm going to show you both methods. The point P, 4, negative 5, is a point on the terminal side, so same exact wording. So if you want to pause and actually try the problem yourself, you can. All right, so here's my initial side. I'm going to do the picture method first. So 4, -5 would be around here. I'm going to call this P. That's my terminal side. Theta would be this big angle there. Or that's theta. I'm going to draw my triangle. I'm going to go from P, go straight to the x-axis, and this is my right triangle. Right? Now labeling these sides, this is 4, this is -5. You would do the Pythagorean theorem to find the hypotenuse. It's the square root of 41. And now you could do SOHCAHTOA from here. So sine of theta is equal to -5 root 41 over 41. This is the final rationalized answer. Cosine of theta is 4 root 41 over 41. Tangent of theta is -5/4. Cosecant of theta, negative root 41 over 5. Secant of theta, root 41 over 4. -4/5. So those would be all your values. Let me show you the problem. By the way, I forgot to label, this would be theta prime in here. That's the reference angle. All right, so let me show you how to do the same exact problem using those little memorized statements that we wrote down. So 4 is your x value. -5 is your y value. And then you would have to do the Pythagorean theorem still to figure out your r value. Right? So sine of theta, right? If you memorize those other values, sine of theta is y over r. So instead of drawing a picture, you would just do -5 over the square root of 41 and then rationalize it. This avoids drawing all the picture. Cosine of theta is equal to x over r. The x value is 4 over the square root of 41, right? And then you rationalize that. And tangent of theta is y over r. Oh, sorry, y over x. So that is -5 over 4. And then you do the reciprocals to get the other values. All right, so that's an option. It's totally up to you which one you do. We will end up memorizing these anyway, these rules that we just did. Sine is y over r, cosine is x over r, tangent is y over x. We will memorize that because it's going to show up big time in the next section. Okay, the next part is finding reference angles. This is part 2 of the lesson, kind of changing gears a little bit, talking more about what are those reference angles. So this is supposed to be a theta symbol. When I convert from the smartboard on my MacBook to I'm doing this on the iPad, some symbols don't come out, so I apologize for that. Okay, so reference angles we just talked about before. I drew the picture for you. Here's the definition. The reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. It's a lot of words, but let's just draw a picture and talk about it. So if we have an angle, all right, here's my initial side, and then we're going to stay in quadrant 1. Right? Here's my terminal side. Here's theta. The reference angle is the positive acute angle. So it has to be a positive number, and it has to be a number between 0 and 90. Right? That's all that means. Positive and between 0 through 90 degrees. It's formed by the terminal side of theta. So the terminal side is this guy right now, and the x-axis. So you would go from the terminal side to the nearest x-axis, right, which is here. So this pink angle is theta, the reference angle, sorry. which we label as theta prime. That's the reference angle. So in this case, theta and the reference angle are the same angle, right? Let's draw another quadrant. Right? So here's my initial side. Here's my terminal side. Here's theta. So following the definition of what a reference angle is, you find the terminal side, and then you go to the nearest x-axis, right? And if you go to the other x-axis, right, if you go the wrong way by accident, look at that angle, it's going to be obtuse, right? And ours has to be acute. So you'll hopefully realize you're doing something wrong. If when you say your reference angle is 120 degrees, that should be really wrong, because your reference angle should always be a number between 0 and 90, right? So this angle here would be your reference angle, right? And we can repeat this for all the quadrants. I guess should do that for you guys. And you'll notice that these are all your bow tie angles. So initial side, terminal side, here's theta, that big angle. Right, by the definition of reference angle, we find the terminal side, which is this. Go straight to the nearest x-axis. So this pink angle is your reference angle, right? And then one more quadrant. Here's my initial side. Here's my terminal side. Here's my theta. My reference angle, find the terminal side, go to the nearest x-axis. This pink angle is your reference angle. So notice it's your bow tie, right? If I put all these pictures together into one coordinate plane, I take all these pink triangles, it looks something like this, right? It's one of these right triangles, and theta is always right, theta prime, that reference angle, is always right near that 0, 0 origin. Okay, so we're going to give you angles, and you have to find the reference angle. At first, this is going to be like you're going to have to draw, maybe some of people draw a picture and figure this out that way. The goal is to be able to find this answer like in under 30 seconds with no picture. This is something, again, that you want to be able to do off the top of your head. So angle 105. So here is my initial side. I'm going to draw theta right now. This is, remember, this is 90 degrees. This is 180 degrees. So 105 would be right around here. Right? So here's my theta, 105. I'm then going to find the terminal side. Drop straight down to the x-axis. And the question is, how many degrees is that theta prime? Right? How many degrees is that reference angle? And the way we figure this out, I know that the full from this initial side all the way, that semicircle there, that's 180 degrees. And I'm subtracting the blue theta from that. So minus 105. So our theta prime here is 75 degrees. Right? Next picture. Negative 115. So I'm going to draw the angle first. There's my initial side. Negative 115 puts me right around here. Right? The reference angle, find the terminal side, and here's the most common mistake, right? Go to the nearest x-axis. So nearest x-axis brings me this way. Right? Notice it's part of that bow tie. There's your right triangle. So here I'm going to do, to find theta prime, I'm going to do 180, because I know this is a full 180 degrees. Yes, it's in the negative direction, but this is 180 degrees. And I'm subtracting the 115, right? So that pink angle, right, of the total 180, that pink angle is only 65. So my reference angle is 65 degrees. And use that prime symbol there so we know that you're talking about the reference angle, not the angle itself. All right, 310. Initial side, right? This is 90, this is 180, this is 270, this is back to 360, right? So I'm gonna go all the way around. Right, there's my terminal side. So find the terminal side, go to this nearest x-axis. This is my reference angle. So my reference angle here, it's almost a full rotation, right? It's 360 degrees, but I'm subtracting 310. So my reference angle here is 50 degrees, right? On this, I'm able to visualize and get these reference angles. There are formulas you can memorize, right? For people who like to memorize stuff, that's not me. All right, so if you like to memorize stuff, if you're in quadrant 1, right, your theta prime is equal to your theta. If you're in quadrant 2, your theta prime is 180 minus theta. If you're in quadrant 3, your theta prime is theta minus 180. And if you're in quadrant 4, your theta prime, your reference angle, is found by doing 360 minus theta, right? This is such an important skill. As we move forward, if you cannot find a reference angle, you basically cannot do the rest of the chapter. Yeah, you need to know how to do this, right? So we're going to spend some time on this. If you have questions, ask. Some people get it faster than others, so just be patient with yourself. Keep asking questions, but eventually it will hopefully click. And once it clicks, you'll be like, oh, okay, I got it. We're good. And it'll make everything so much easier. So important things to remember about reference angles, right? It must be a positive acute angle, and the reference angle is formed from the terminal side to the x-axis, right? Susie, mistake to go to the y-axis. So if you by accident go to the wrong side, right, you might end up giving like big red flag if you say your answer is 100 degrees for your reference angle. Big red flag because it has to be a number between 0 and 90. Let's just do one more example. If theta is negative 45 degrees. Right. So I just want to show you a common wrong answer I get. So here's theta, right? This was negative 45 degrees. You're going clockwise. The reference angle, in this case, right, here's the terminal side. Go to the nearest x-axis. This is your theta prime here in pink. Here, your theta and your theta prime are pretty much the same thing, but it's 45 degrees. Common mistake is to say negative 45 degrees. Remember, it has to be a positive acute angle, right? Positive acute angle. If you say negative 45 degrees for your theta prime, for your reference angle, big red flag because it cannot be a negative answer. All right, check Google Classroom for your homework. I'll be online for office hours. Check that out what time that is, and make sure you come ask questions if you're confused. All right, guys, have a good day.